It gives me the time to read again the background of our first speaker. So our first speaker is Arno Wess, who is working at Envigo. He studied biology, chemistry, toxicology. He did a dissertation on QSAR modeling, so it might be very interesting for the discussion in the break if you have information to request on that. He worked for the pharmaceutical industry, and since 7 years he is at Envigo, who is a consulting team where he is lead consultant. And Arno is focusing on SVHC, substance of area concern, ecotoxicology, environmental fate, and his knowledge comprises difficult substances, mixtures, metals, category approach, and read across. And I'm very happy because if you have really complex question on substance identification, we have an expert. So Arno, the floor is yours.
Thank you. Yeah, thanks, Crystal, for the nice introduction. And I would like to emphasize first, because there were some critical words about consultants explaining everything with QSAR and read across. This is what we are definitely not, because we have a large lab. Anyhow, substance identity is an important task. This has also been already pointed out. And before you go to registration, you need to pre-register, and once you have pre-registered for the same compound, it's not easy to get out anymore. And I have experienced some cases where substance identity was a very problematic issue within Substance Information Exchange Forum, and where it came out at the end that it is maybe questionable whether the registrants have actually the same substance. But anyhow, next slide, please. Or I can control. So, yeah. So therefore, I will guide you first to the 3 categories of substances that are known under REACH and that you can choose in the pre-registration. Then we have some slides about the analysis, and at the end, no surprise, the quality advice. This is a very serious phrase. Correct and unambiguous substance identification is a frequent shortcoming in registration dossiers. And the reason for this are multiple. Some suppliers in the supply chain just do not know very much about what they deliver, about the composition. Others are reluctant to reveal it, and if they're out of European Union, then you encounter a serious problem. On the other hand, of course, you can choose your suppliers, but you are the ones who have to solve the problem, because as the registrant, you are in the role to be urged to supply the information. On the other hand, there may be situations where it turns out that you actually can you can jump out about an existing pre-registration and make a new one if this is properly justified, but there is a deadline this year. And therefore the advice is very simple: take care of substance identity right now. So this looks, on the first view, looks simple. 3 substance categories. The monoconstituent, or 80% or more, is one substance. Second, multi-constituent substance. There is a number of constituents, but none of them is higher than 80. Multiple constituents are existing in the range of larger than 10 and less than 80%. This is just mathematics. And impurities are possible. Normally, impurities needs to be characterized as much as possible, but there is no possibility to catch every molecule. And then in the last category, it turns to be very complicated. To make a substance definition of a substance which is undefined. And this is the U. Undefined, variable, complex biological materials. The definition of a UVCB bases on starting materials and process. Impurities, by definition, do not exist because all is variable in these components, in these substances. The starting materials can also be UVCB, or they can be different. So here is the first potential pitfall is, if you use a natural material, wood for example, what is the wood you're using? This can be related to impurities that have impact on classification. Even if it's plant material or wood, there are woods used to get undesirable substances out of the soil, and they are marketed later on. And if you use them in a starting process, then you may carry with them unpleasant compounds. So first, the case that one would expect to be the simplest one. A monoconstituent substance, more than 80% defined. 80% of what? Mass without water, in principle. Or added solvents, of course, do not count anyhow. So it's the dry material. All the people dealing with inorganics would probably immediately think on, oh, what about crystal water? Yeah. Is crystal water that may be present in more than just one relation to the pure cations and anions? How are they counted in this summation process? There's something to get clear on, and there is no easy answer. Particularly not continue with the inorganics, impurities, if these materials are derived from ores, so this is from natural sources, and you actually do not know what there will be if you take out all the water. So can you analyze? Can you give information on that? There may be unclear situations. And if you look at this picture, so you have a single substance with 80% or more. The remainder are impurities that need identification, generally if they contribute to 1% or more, or even less if they are hazardous, which means how can you judge whether they are hazardous if you don't know? So therefore, you should know, or you should have reason to exclude that a substance of 0.1% or higher is dangerous. So the easiest, okay, if you make HPLC and you look at lipophilicity, this gives you a hint of a compound can, at least because of lipophilicity, be excluded from being hazardous. And by definition, you have to come up and to agree within the registration to a composition to add to 100%, but you can use ranges. And the range may start with 0 if a compound is potentially absent, and sum up to higher degrees, 10, 20 or more. This holds true particularly if the process used to produce this single substance material is different. 80% or more. So some may have a purity of 99.99%, others of just around 80% if it's a technical material. And there's a large room for additional constituents. There's one case, if in the production process a starting material is used that is not fully consumed in the chemical reaction producing the main constituent, then this starting material can also be considered a reminder of a mixture. And this opens the possibility to consider whether this is actually a compound of its own to be registered, but then you must consider to be in a different sieve to get access to the data of this reminder, to this impurity, which is, depending on the view, maybe not an impurity, but a reminder of a starting material, and then it could be considered a mixture, and this would change a lot of things: sieves, pre-registration, data sharing. Always consider, if you are in a substance information exchange forum, then you have, normally without problem, access to all data. But if you need data from a different substance where you are not in the sieve, then there is no easy process, no simple right to get data access, but it may be crucial. Next case is the multi-constituent substance. So by definition, it must be excluded that a single constituent has 80% or more. The remainder is then in the mathematically defined range, and here there is no impurities unless they are resulting from the starting materials. So all is then considered to be the products of a chemical synthesis process that leads to the compound that is intended to be registered. And here it is important to distinguish between mixtures and substances that are produced as a reaction mass together. The point is maybe most critical in terms of the joint classification that you require, as there was a change between the Substance and Products Directive and the GHS. While in the Products Directive, the process of intentional mixture was leading you to a different classification process based on the individuals. Now, there is no distinction any longer. This means that every substance is a mixture. You have no 100% pure substance. But all impurities are to be considered for classification also. So there is a significant change in the right, and normally if you have standard materials, the critical compounds for classification are often not the main constituents, but impurities. For example, metals. If it's cobalt, then you have a CMR. Yeah, so this is the way the things interact. And you need to agree in your sieve with a composition that covers all. And you may have different production processes, different starting materials, carrying with them individual impurities. So therefore, go deep and look what you actually have. And in theory, I do not know whether this holds true, but I have seen considerations of it, but maybe Crystal can give us a short and deeper advice. There is a theoretical possibility to register the main compounds as 4 single substances, and then, however they are marked together, hold the registration of the constituents instead of registering the mixture. This would, as the most important point, give you direct access to the data of the main constituents. Next is, as already said, the most critical. That's the undefined variable complex biological materials. And they are defined by starting materials and process. And this is normally done in a short CAS definition, where it is leaves of a plant, and then you get the binary nomenclature from Linné, which is a plant species, and the process, how this is extracted. And this all comes together in one registration. Well, there can be significant differences. An example that should be quite popular is cannabis. So there is a large number of different qualities, and the ones who use it would be aware of the effects can be terribly different. It depends on the plant, where the plant was growing and how it was grown. And the constituent, THC, that makes the effect may be present in a very large range. So things turn to be complicated. And it's not just enough to state in the dossier, yeah, this is unknowns, 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 all less than 10%, so it's unknown. This is definitely not enough and will not be accepted. So you need to go deeper. You need to characterize what you have. And in this case, at variance to the multiple constituent substance, it's not enough to take just one sample and to analyze, because it's variable. So you need to collect different samples and get aware of what is the variability within all materials registered. This is the clear expectation of the authorities. So it is significant work to get clear of that. There have been procedures proposed to sample over a year all individual materials that you can get, then to mix them and make an overall analysis. Maybe suitable, maybe not. This is all discussion, and the moment to get clear on this and to get authority advice on your individual case is right now, as I said already. So yeah, this is what you then would have. If you look at a chromatogram of such material, you have multiple compounds and most of them unimportant. General rule is 10% or higher occurring compounds should be named. Therefore, a mixed sample where you mix down more components to less than 10 may be not acceptable. Yeah. The next point is categorize the compounds. So a lot of compounds in such materials may be similar in behavior, similar in properties that become visible in chromatograms, and maybe you can conclude on their chemical nature, and this is something to be done in the most careful way possible to get almost precise picture what is actually the substance registered. And now you can probably understand what Crystal just said, that there have been an improvement in the new Euclid 6. This means that for every test that you make, you do not just state as it used to be, yes, it's the same as in the substance definition. No, you need to go to a linked sheet, a linked table, and define as good as you can what has actually been tested. This individual material, and as I just said, the global substance definition needs to cover all. But this definition, then to be made for an individual test, a specific lot, is much more precise and has to. And this is important if you discuss a situation where the same substance to be registered, so the submission item, behaves different in different tests. Then normally the explanation, if it's a UVCB, would be, well, the testing materials were not chemically identical. So the types of analysis required are to conclude on the basic identity of a compound, then on the detailed identity, and next on the purity. Here you have the standard means UV spectroscopy, IR spectroscopy, of course, NMR and mass spectroscopy, and for the purity, normally gas chromatography or HPLC. The spectral coverage, of course, is to be maximized, not to overlook something. And here you have some hints about the ranges that are recommendable. The additional characterization, if whenever possible or suitable or accessible, for example, for means of quality assurance and so on, of course, should be used. There's a standard list that the software and the quality checks require. And of course, if something does not work for a compound, which can always happen, then proper justification is required. So here you have some hints for potential additional methods for analytics, which are not worth to go in deeper right now, unless you have questions on that. And here, this is, to me, it's sometimes surprising, but such simple things as the analysis date or a laboratory name or a batch number are sometimes missing. I have encountered situations where only the batch number was the information that was leading to the natural of a compound that has been used in a test, because there were different namings used, trivial names, for different compounds, and the test report had just the information of a trivial name. So it was, after 20 years, not possible any longer to say, hey, what was actually the chemical tested here? It was from a company that has been merged and then sold again, and nobody knew. Nobody was knowing. But the batch gave then the way back to the production side, and there was information available how it was produced and what the range of possible chemicals produced there was. So traceability is an issue, and here is just the head of the information that should be on these documents. And here some hints for the basic information and how to structure them for use then in the section 1 of the Euclid. It is not the task of the lead registrant to solve this problem. So this is the task of every individual registrant. So you need to give all this spectral information with your registration. I come to the conclusion. So, the registrant is fully responsible for the identity of the substance. And there may be questions to be clarified as long as there is still time to clarify. Defined substance categories have been created and were presented. The analytics section and quality are vital for the identity justification, of course, and incomplete identification is not excused. So there is no easy way out, and if you have substance identity issues, then you will quite probably encounter some discussions and dialogues with ECHA. So this ends my presentation.